Good day, everyone, and welcome. My name is Sanjay Nagmangalam, and I'm a product manager at Snowflake. I have two topics for today. The first topic is I'll introduce you to the Snowflake Native SDK for connectors. What is it and why you should care? And the second, we have a special guest, Nate from GitLab, who's here with us to share real-world insights from their experience using this SDK to build their own connector. So let's get started. So, what customer problem are we really looking to solve with the Snowflake native SDK for connectors? Now, in speaking to developers and third-party ISVs and customers, we learned a few things. Customers and developers need a way to easily bring data from external systems into Snowflake. In addition, they wish to keep the data in Snowflake up to date, perhaps at a refresh frequency that they choose when the source data changes. Now, developers are very familiar with existing affordances in Snowflake to monitor, troubleshoot, and they want to enjoy the same affordances, the same experience with the connectors that they create. And lastly, ISVs seek to distribute their connectors on the Snowflake marketplace to offer it to other customers to consume in our rich app ecosystem. Now, while developers know their own data sources well, the friction they face is creating the plumbing for connectors for Snowflake. It often takes them too long to learn new concepts, develop, test, debug, deploy, package, and publish their connectors, which in turn negatively impacts their time to market. This is where the Snowflake native SDK for connectors comes in. We turned what we learned from customers into a set of requirements for us as we were creating the SDK. Essentially, developers can use our SDK to focus on their business problem instead of what I call connector plumbing. So the SDK bootstraps the task of creating a connector for Snowflake from any custom data source end to end. It has ready to use components that you can glue together for data ingestion, periodic refresh, ETL or ELT, and it also creates a ready to use Streamlit app for you to configure the connector. And lastly, we have recipes for you to copy, paste, tweak, and customize for your own use cases. So the SDK packages all of this into a Snowflake native app that can then be published on the Snowflake marketplace for others to use. So with that context, let's go deeper into a couple of patterns that we see. Now, broadly speaking, we see two patterns where customers want to ingest data from an external data source into Snowflake. The first one on the left is what we call a pull-based pattern. And the one on the right is the push-based pattern. And we have customer use cases for both. As the picture on the left shows, a pull-based pattern is useful when the data provider does not manage customer data in Snowflake, and the data source perhaps has a well-defined set of APIs for consumers to pull information. So, for example, things like Google Drive or SharePoint or even GitHub or other systems. In the pull-based pattern, the native app, the connector sitting in Snowflake, connects to the external data source via APIs and external access in Snowflake to go fetch that data as needed, perhaps on a schedule. Now, the SDK supports the pull-based pattern out of the box. And then there's the push-based pattern. As the picture on the right shows, this pattern is useful when the external data source does not have an API, or perhaps the access to the data is not possible due to performance or security considerations, like firewall issues. In this pattern, we offer an agent that runs within the customer's network boundary and essentially phones home to the native app, the connector sitting in Snowflake. While the SDK does not support this pattern out of the box, we have extensive samples and documentation in our GitHub repo for you to go copy, paste, tweak for your own needs. In either pattern, the native app sitting in Snowflake is the brains of the connector, right? So let's see some of this in action. I'll go to a demo here. So for my demo use case, here's what I wanted to do. What I wanted to do was create a connector using the Snowflake native SDK for connectors that does four things. Number one, connect to GitHub via OAuth. Number two, fetch issues for a public repo that I can go specify. Then take those issues and put them in a database in Snowflake that I specify again. And then use the scheduler component in the SDK to refresh this data periodically. And then lastly, of course, I want all this packaged as a rich, nice native app with UI to configure the connector and publish that app onto the Snowflake marketplace. So what I'm showing you here is Visual Studio Code. And what I've done basically is I've cloned our GitHub repo, updated a few parameters, and essentially written my fetch logic and built the source code to create a native app with UI based on the SDK that does the four things I mentioned before. So looking at the source code here, the Streamlit app is here. It's part of the SDK here for you to go tweak and reuse. All of the connection management logic is here, which was fairly trivial to write because the plumbing was already there. And when I build this app in Visual Studio Code, out pops a native app that's published to the Snowflake marketplace. So I showed you what the source code looked like in Visual Studio Code. And after I built it and deployed it, basically I switched over to my Snowsite interface to show you what the app looks like. So if I click on apps here, I hope to find my demo app right here, as you can see. This app essentially is the output from the Visual Studio Code project. Let me click on this app to launch it. And while it's launching, all of this Streamlit UI was generated by the SDK for you to go use. All right, so let me start with the data sync settings and show you a few parameters. So remember, the purpose of this app was to go fetch issues from a couple of public GitHub repos. These are the two repos that I specified. And what this app is doing essentially is on a cron job. It's using the GitHub API through OAuth, through an external access in Snowflake, and then fetching issues programmatically, and then putting those issues in a database in Snowflake, right? The home page shows a few stats and stuff like that. Having said this, let me actually show you what the data looks like in Snowflake. So let me go back home and I'll go to my demo here. And I basically have two very simple queries. I'll run the first one. And this is what the data this is the data that the connector pulled. These are the actual issues. Let me run that too. If you notice, the connector actually helped create a view on top of a table. You can customize all of this, but for demo purposes, that's what we did. There you have it. I mean, essentially a very, very quick demo of a fully functional connector. The SDK created all the plumbing for me, including the Streamlit UI to configure and manage the connector. It even published the native app on the marketplace for me to go test. Now, I created this connector from scratch last night just for this demo. And the SDK helped bootstrap me, and I was able to do this very, very quickly. For what it's worth, I spent more time setting up the GitHub app for OAuth 2 than writing the business logic to fetch that data. So this completes the first part of my agenda. On to the pièce de résistance, the second part. Let me pass it on to Nate from GitLab to share his insights from their experience using this SDK to build their own connector. Nate, over to you.
Thanks, Sanjay. My name is Nate Rosendich, and I am the engineering manager at GitLab. I manage the compliance group. I'm going to talk to you today about the data connector that we built to connect customers' GitLab data into Snowflake. At GitLab, the compliance group is in charge of building functionality to help our customers with their compliance posture, both from a reactive and proactive stance. Proactive being things like compliance frameworks and compliance pipelines for enforcement, but the reactive side being the audit event system that we have built to analyze and understand what is happening throughout the software development lifecycle within GitLab and allowing our customers to get certifications like SOC 2 and ISO 27001 and work with auditors. As part of this system, what we do is we also stream this data out of GitLab to different data storage. And as part of our product research, we realized that Snowflake is going to be a critical part of this to allow our customers to store this, analyze this data, and understand what's happening at scale. So this was a critical part of it. As part of our solution, we investigated both looking at push-based APIs, so pushing it from GitLab, this data into Snowflake, using the Snowpipe streaming, but we found that this was going to be probably cost prohibitive due to the large scale of events that we are streaming through. So this is when we decided to engage Snowflake directly and begin to utilize the native SDK for connectors. As Sanjay mentioned, there is both the push and pull-based approaches. We explored both of them and realized that the pull-based approach from the native SDK was going to be perfect for us for being able to control and gather the data that our customers required. So this connector authenticates with the GitLab instance and then imports GitLab data directly from there into Snowflake using the APIs. Using the native SDK, we were able to quickly develop a proof of concept. And I think Sanjay just mentioned being able to do it overnight very quickly. We were also able to create a proof of concept very quickly to beta test using one of our APIs very quickly. And we have a very short time frame to roll out this application. From here, we were able to expand that out to all of our audit event APIs and get that data flowing into Snowflake and be able to show how to analyze and view and understand this data within Snowflake. With the success of the initial proof of concept, we were able to quickly expand it out from not just the audit events data, but also things like projects, groups, users, and merge request data. So other parts of the GitLab product that we hadn't initially thought that this connector would allow us to do. So this was a huge benefit for us, and this allows our customers to have a more comprehensive compliance picture, not just the audit events, but anything else. And we're looking at expanding it out to more APIs as we go and releasing new versions very quickly. So now I'll just go through a quick demo of how to find, load, and connect our GitLab Data Connector within the Snowflake marketplace. So here I have a Snowflake instance, and I can search from the home or from within the marketplace, GitLab, and we should see the connector show up within the marketplace here. If you click on here, we have information about it, and you can see that I've already installed it. So once the connector app is installed, there'll be some configuration steps. There are a few prerequisites that are required to get this connected. Of course, the first one being both a Snowflake instance, as I've got here, a GitLab account, and so making sure that you have a group or projects that and the correct license to be able to do this, a personal access token within GitLab to be able to allow the connector app to connect to the GitLab instance, and also an external access integration. You can read more about that, but as this connector app pulls information directly from GitLab, you need to allow that to allow that integration. And then the next step is to actually set up this configuration. So the first one is to grant privileges as we create databases and execute the cron tasks in the background to pull the data. Choose which warehouse that you want this information to be supplied into, and then creating a destination database and schema to name this information when it comes across. The third step is the connection configuration. So this is the external access integration, and I have set this up previously by executing some commands to store this in the background. And so we have access integration. We also have the secret that you created in your GitLab API token. And so we can add that in there. And then the instance domain. Most likely this will be gitlab.com, but I also, for this particular demo, we're using the staging account. And then if we click through to connect, we should come through to this page where we start seeing the data to connect. And as Sanjay showed before, there are the other tabs to show how often that this data sync is happening, and the particular groups, projects that you want enabled, and other settings that we've already configured within this connector, both the connection configuration and the connector. So you can see the staging.GitLab. And now I should be able to go, well, you can see the data coming through here. And if I go to our schema, we can see our audit events table set up here for both group, instance, projects, and users. And if I click into one of these, we should be able to see some of the data coming through here. So now down to some of what we learnt while developing this application. And as we were using this native SDK, getting access to logs for quicker development cycles, we realized was going to be critical for our developers to be able to keep up productivity and keeping to the timeframes that we had. As this application is hosted in the third-party marketplace, we realized that access is not going to be, it was going to become a problem fairly quickly, especially as we start rolling this out to customers. So what we did is we implemented a independent logging table within the application. We then used loggers for both the Java and SQL code using the system logs to push logs to there. And this gave us immediate access to both the code and database logs and allowing us to see issues and solve them quickly during the development lifecycle, but also once the application was in production and allowing us to understand things like migrations where customers were having a few issues there. Java is not a major part of GitLab stack, so there was a little bit of upskilling involved in getting this to this point, and so logging was also a critical piece for making sure that everyone within the team understood exactly what was happening during this building this application. The second most important thing that we learned while developing the application was creating separate database migrations. The default migration process within the native SDK was creating one SQL file and adding the migrations to it. This quickly grew to hundreds, thousands of lines of code, which became unmaintainable for us to be able to understand exactly what was happening for each migration process. So we implemented a process to split this into separate files, allowing us to debug each migration quickly and allow us to release new migrations and new versions of the application quite quickly while keeping it maintainable. We have some examples of that in some of the materials as well. Third thing was automating the deployments. We built this using GitLab's CI/CD pipeline system and automating the creation of each release and automating the deployment process was important for us to make sure that all developers, as I mentioned, were starting to learn some of this, could quickly release new versions. And the native SDK has some pre-built deployment tasks that are required before creating new releases, such as security scanning, things like that, and adding that within our pipelines has just made this process so much more easy for us and means that our cycle times are down and removing a lot of confusion for us while developing it. And the final thing that we really learned was testing. And I'm sure this is not a new thing for anyone who's in engineering, but making sure that we could quickly scale this through our different migrations and different versions as we added new tables, new APIs, making sure that we had tests and could migrate over we had migrations to the connector from Maven Central, things like that, making sure that all those processes were in line was critical for us as well. Yeah, so from there, I'll pass it back to Sanjay.
Thanks a lot, Nate, for sharing your experiences, your insights, and best practices with us while taking us on the journey as you built the GitLab connector for Snowflake using the SDK. To wrap it up, we showed you the Snowflake Native SDK for connectors and how it can help accelerate your time to value when you want to bring data from an external data source into Snowflake. Now, I have three links here. One's the documentation, the second's the tutorial, and the third is our GitHub repo. I invite you to scan these QR codes and try the SDK today and tell us what you think. We trust this session was useful to you. Thank you again for your time today.
And thank you, Sanjay, as well, for this opportunity to talk through our experiences. Hopefully, you all found it very valuable and will take some learnings away as well. And please go out and try the GitLab Data Connector. Thank you.